Welcome to our streaming capture video. We'll start off with a setup in which we are automatically capturing SPI data streams, decoding them using our protocol decoder, and displaying a swept frequency signal generator which is sweeping between 1 Hz and 100 kHz using a log sweep at 10 steps per decade. You can see the sweeping going on here. Here's some digital inputs that are coming from a LaCroix signal generator, which is also making the SPI settings. We're going to capture our streaming data at 1 megasample per second using 14-bit resolution. We're going to save our data to stream as a base name using 100 megabyte files. Okay, let's turn off auto and start streaming. Here we go, we're capturing at 1 second per division, and we'll go and see how this is all progressing tomorrow morning in about 10 hours time. See you then. Good morning. We've captured nearly 10 hours 22 minutes at 1 megasample per second. We've done 37.4 gigasamples of storage. That's equivalent of 274 gigabytes. While recording, we can pause the capture and zoom in like this. And here we can see the structure of what we've been capturing. This is the sweep that's still going on. We're still capturing right now, but we're just reviewing the information we've already seen. We can see up here, each of these is an individual SPI message. Let's zoom in on one. So there's the messages. You can see each of the individual pulses. Everything's been captured at 1 megasample per second. We can open the tracking graph and use it in real life as it captures. You can see I'll move it over here. Tracking graph is tracking what we've captured. We can go and look at something with much more detail. We can open the spectrum display and show the spectra of a chunk of the scope display as we're capturing live. Here's the spectrum display. This is the spectra of this portion of the waveform. I move it across here and we move the waveform. You can see the spectra changing as we move across it. We can open the signal information display and see signal information about the portion of the waveform that we're looking at. This, for example, is running at 61 kilohertz. We move to a different portion. It's 48.77 kilohertz. Finally, let's stop capturing, and then we'll see how we can review. We stop capturing by clicking the stream button. And it's done. So now we can review where we are and move to any portion of the graph as required. So here we are, and we can see that we can go from 30,000 seconds to 37,000 seconds. Anywhere in there, we could just zoom in on a portion. For example, this one here. Yeah, there we go. Let's see if we can do some protocol analysis on the thing that we captured. So here's a little message. And we'll click decode protocol on, and there we are, decoded LaCroix SPI message number 34. The signal data has been saved to disk as we go. However, we can save the current setup by going save, and then we can open another file which is way over here. Notice how the dock works. Now we can reopen the streaming file we just captured overnight by going File, Open, and we see it in the file list. There it is, 38 kiloseconds long, and we can zoom in again on any portion. And there are those individual messages. And we can click on Decode Protocol to decode the protocol. There it is. We see it's another message, LaCroix SPI 90 this time. And again, we can use all the standard tools. For example, open the tracking display. And go and individually look at samples in the tracking display, like this. And of course all the other tools that we've got, maths, spectrum, the signal information. We can save chunks of the waveform to disk for review by third parties using binary or text save, and we can annotate the graphs as required. So there you have it, streaming. We can stream many gigasamples of data to the hard drive, and then we can go and review them very quickly. As you can see, if we do a fit, it takes almost no time. That's 38,000 seconds we fitted, more than 10 hours of capture. Here we can see the real detail. Sample rate 1 MHz, 38.1 gigasamples, and 10 hours of capture. Streaming is a way of capturing very long-term information at high rate and then interrogating it using the spectrum display, maths, the tracking graph, signal information, and transfer to MATLAB for useful information that is almost impossible to find any other way. We hope you like it.